This is a lesson on the introduction to the next unit, geometric sequences and series, short little unit. So to begin with, we take a look at geometric sequences, get the definitions down, and then do a few questions, simple questions based on that. So a geometric sequence is an ordered list of numbers separated by commas where each number, which we'll call a term, is multiplied by a constant in order to produce the next term. And then this constant would be referred to hereafter as the common ratio, which is symbolized by R. So all this means is that when we have a geometric sequence in front of us, the pattern will be such that you're always multiplying by the same number to produce the next number. So this example illustrates it fairly well. It's not just a random assortment of numbers, but there is a pattern. 5 multiplied by 2 is 10. 10 multiplied by 2 is 20. 20 multiplied by 2 is 40. And the geometric sequence must have that same multiplier, the same common ratio, always. Otherwise, it's not a geometric sequence. And this other one, 2, 1, 1/2, 1/4, 1/8, is also a geometric sequence. The numbers aren't quite as easy to work with, but it still is. Now, if we go back to these two examples, a couple of little observation things. We would call this an infinite geometric sequence with common ratio R equal to 2. The infinite just means it goes on forever. And that would be as opposed to the second one, which is a finite geometric sequence, because this one ends at 1/8. It's a small distinction, but something you want to be aware of. And the second one has a common ratio of 1/2, because you're always multiplying by 1/2 to produce the next term. So always be careful. Like a lot of the times the common ratio you can tell by inspection, because you think division. But you're in fact not dividing by 2, you're multiplying by 1/2, and that's how you need to express those ones. So let's take a look at a very basic geometric pattern. 2, 6, 18, 54, 162, etc. Also, as was indicated in the definition, the terms are going to be separated by commas. The symbol for the first term, 2, is just T1 with a subscript of 1. That's often how they write them. 6, the second term is T2, then T3, and I won't bore you with all the other ones, T4 and T5, but the nth term would be just any term in the sequence. So that's just the general term. So I'll go any term, or if you like, they'll frequently refer to it as the general term. So you could either refer to a specific term or just a general term. And something else, the first term T1 is also symbolized by A. So usually, in all the formulas we'll work with, we'll call that T1 as A. And when you're dealing with a common ratio, you can find it by inspection like we did, for some of the previous things, or we can use a formula. And the formula, it's not a really sophisticated formula, is just the nth term, any term, divided by the term before it. And that's what it means. Those refer to consecutive terms. So Tn divided by Tn minus 1, just consecutive terms. And it really means, in practical terms, that the common ratio would be equal to T2 divided by T1, or if you prefer, T3 divided by T2, or T4 divided by 3, etc. like that. You just take consecutive pairs of terms and divide. The common ratio, I repeat, should be the same for whichever pair you select. So the common ratio just can't change halfway through. If it does, then you've got a different sequence in front of you. So let's do a few questions where you're just simply asked to identify the A and the R in each of the following. So for the first one, -2, 6, -18, 54, a finite sequence. And A, by inspection, is just equal to -2. So don't make that complicated. It's just a matter of looking at it and seeing what the first term is. Now I went ahead a little bit, but the common ratio is T2 divided by T1 or T3 divided by T2, whichever pair you want. Usually it's easiest with the first two. So we take 6 divided by -2, which is therefore equal to -3. So the common ratio equal to -3. And you'll see that if you had gone -18 divided by 6 produces the same. 54 divided by -18 also gives you -3. Let's do a few more. So this one's got fractions. Fractions are always harder to tell the common ratio by inspection, and you want to be careful with it. But let's get the A first. A is just equal to 1/2. That's the start of the sequence. And then your common ratio, Tn divided by Tn minus 1. So I'm just going to go T2 divided by T1. So 1 over 10 divided by 1 over 2. You have a complex fraction, which was simplified to 1 over 10 divided by 1 over 2, which I will write as 2 over 1, multiplication. When you simplify that fraction, you'll get 1 over 5. And there we go. There's our common ratio. And you know, if you look at that, you can see, okay, that makes sense because you're multiplying by 1 on top to produce the numerator. You're always multiplying by 5 on the bottom to produce the denominator. You shouldn't make mistakes with the A and the R because really it's just a matter of doing the same thing every time and being careful. This one, you probably can't tell by inspection what the common ratio is either. The A you can. A is equal to 0.1. And then the common ratio is equal to T2 divided by T1. So 0.5 divided by 0.1. Now if you use a calculator, which you may want to do in this case, it's a little bit easier than actually trying to turn these into fractions. So 0.05 divided by 0.1, and you will get a common ratio of 0.5. You could also try R is equal to T3 divided by T2 if you wanted to, but you will get the same thing. 0.025 divided by 0.05 will also produce a common ratio of 0.5. So it doesn't make any difference. Choose what is convenient. And for number 4, no problem with the A value because it's stated in the question, it's the first term, A is 10, but your common ratio, well, it's hard to know which is the best way to do it. You will get a slightly different looking answer depending on which one you select, but that's just because in one case the radical is rationalized, in another case it is not. I'll keep it like this, 5 root 2 divided by 10. And when you simplify by dividing by 5, top and bottom, you get root 2 over 2. Good enough. The next batch of questions, I'm actually only going to do one, is a really common exam type problem. And they're solved a specific way. It's hard to fumble your way through these ones, so you want to be careful with this method. Here we're asked to find the value of x so that the first 3 terms of a geometric sequence are x, x plus 3, 4x. Determine the value of the first 3 terms and the common ratio. So this is all defined in terms of x, but we really want to find out first off what the value of x is equal to. Once we get that, the second parts of the question should be fairly routine. The method for these is to note that the common ratio is equal to T2 divided by T1. That doesn't do you a lot of good when everything is expressed in terms of x. However, R is also equal to T3 divided by T2. So it might occur to you that the common ratio is equal to both of those. So therefore T2 over T1 must be equal to T3 divided by T2. So you're setting up a proportion. And then you substitute the x values in, and you'll get x plus 3 divided by x is equal to 4x divided by x plus 3. And you simplify this proportion either cross multiplication or by multiplying out your denominators, but you'll get something like x plus 3 squared is equal to 4x times x. Carefully FOIL out the left side, which will give you x squared plus 6x plus 9 is equal to 4x squared. So we have a quadratic in front of us. Bring it all over to one side, and I'll bring it over to the right side, subtract x squared away, and that will give me 3x squared minus 6x minus 9. Now to clean up this quadratic before we factor it, we should divide every term by 3. And if we do that, including the 0, this isn't new math, you've all seen this before, we do end up with a simpler equation. And it just makes the factoring easier, or some of you may choose to use the quadratic formula. No matter, it will break down into x minus 3, and you can check this one out, times x plus 1, and therefore x is equal to positive 3 and negative 1. Now that's the first part of the question. To find the value of the first 3 terms, we just substitute in. Since we have x plus 3, and 4x, now we're going to get 2 sequences from this. For x is equal to 3, we'll get 3, comma 3 plus 3, comma 4 times 3. So that's 3, 6, 12. So your common ratio is equal to 2. Now I'm not doing a lot of work with it, but by inspection, 6 divided by 3 is 2. And then when you do the same thing for x is equal to negative 1, you'll get negative 1, comma negative 1 plus 3, comma negative 1 times 4, which is negative 1, 2, negative 4. And here we're getting the common ratio is negative 2. So you want to be a little bit careful. You can end up with 2 sequences as a result. So that's it for this lesson. The next lesson will give us the formula that we use for geometric sequences, and we'll play around with that a little bit before we get on to the next part of the unit. Thank you for